My name's Harriet. I hack your AI so the bad guys can't. Welcome back, everyone. It's been a minute since I've done the YouTube channel or the podcast, but I'm really excited to be back, and I kind of want to apologize for taking a break, but also every so often I jump onto other YouTubers and content creators and they're like, oh, I'm so sorry for taking a break. And I'm like, I did not realize at all. So if you didn't realize that I'd taken a break, that's really good. But I announced recently that my book with No Starch Press, the AI Security Handbook, a Python-based guide, is now open for pre-release, which is so exciting, and I'm really stoked. But it sort of explains why I haven't been that present on especially YouTube lately. It's been a lot of work running the company and writing the book and finishing my PhD. So now that I've got one of those things off my plate, I'm really excited to be able to use that time and bring it back over here. Something else that you'll notice is that I'm consolidating both YouTube and the podcast. There's a few reasons for that. First of all, it seemed a shame that some content would only go one place and not others, but also I've been traveling a lot and I don't get to be around Tanya all that much anymore. And it felt really hard to schedule in and only have podcast episodes when we were together, or I could be with another member of my team. So from now on, the podcast is going to be me, Harriet, but every so often we'll be joined by guests like Tanya and others. So you'll have to bear with me as I get used to monologuing. I watch other podcasters and YouTubers who are solo and doing it by themselves, and they make it look so easy, but it's really so hard. So bear with me while I get used to it. I'm just going to have to pretend that Tanya or Miranda are right here, but in fact I'm talking to you. So thank you so much for being here and for sticking it out. If you're new here, my name is Harriet Farlow and I run an AI security company called Maleva Security Labs. My PhD is in adversarial machine learning, which is all about hacking machine learning models. And yeah, I've just written this book with No Starch Press. It'll be released at the start of 2026. So here on the podcast and on my YouTube channel, and also over on Instagram and TikTok, I release content on AI security because I just haven't seen much other content or much help or resources on the subject. And I started this channel 2 years ago to raise awareness of AI security, and now that landscape is really, really different. So if you've been listening or watching for a little while, I don't want to repeat a ton of stuff, but I know that there are probably new people here, and at any rate, the field has actually changed quite a lot even over the last few months, and it continues to evolve so fast. Something that I was really conscious of while writing the book. So I started writing it at the end of 2024, and my background is in data science and machine learning. So I come into AI security with a really specific focus based on my background. My background was all about disrupting and compromising machine learning models. And as you're probably familiar, an AI system is an overall system that might use one or many machine learning models, but depending on the frame of reference of whether you're looking at the model or the system, that means very different things for its security. And so machine learning security can be considered quite theoretical because usually you can't actually get to the machine learning model unless you get through many layers of the system itself first. So something that I really noticed while writing the book from December 2024 to September 2025 is the rise of agentic AI. And if I write a second edition, reach out to me. But that is something that I would look at a little bit more. But even so, the reason that there is still that focus on machine learning models is because, honestly, in most organizations, they're not using agentic AI yet. It's the cutting edge research, but my focus has always been on what is currently happening, what is currently used. So today I thought that for this episode, I didn't want to go right back to what is AI security, but I did want to maybe touch on a really common misconception or a common, dilemma or challenge that I get a lot of the time, that does serve as a good introduction to AI security, and that is the question: is AI security really different to application security? Or another way of phrasing that question is, could most AI security challenges be solved by good application security? So that's what I'm going to touch on today. Before I get into it, I would really appreciate if you find any value from what I'm doing here, please follow, like, subscribe, all the things. Write a nice comment if you like. I really do want this channel to grow and become somewhere that people who might not have access to like more formal education options or really expensive courses, where people can come and get good quality insights and education, and maybe we can raise some really cool discussions as well. So if you can help me out, that would be fantastic. And the other thing I want to mention before I start is that another reason I think I felt a bit self-conscious about solo podcasting is because, like I said, I travel all the time, and so I don't usually get access to a nice studio or like a really cool backdrop. As you can see behind me, I don't know, another random place. I feel like I'm always just traveling around different, hotels and Airbnbs and things. So I thought it might be kind of a fun challenge. For each episode, you can guess where I am. So I'll give you one hint, and that as of recording, and it is mid-October, I'm in this city for a cyber conference. So take with that what you will, and that's also a good segue into the topic of today, because I wasn't really sure if I would be in Australia now, and when I realised that I would be in Australia, side chat, one of the reasons that I've also been really busy is because we finally won a big government contract with the Australian government. Which is so exciting and a lot of work. But over the 2.5 years that Maleva has been around, we've actually never worked with an Australian organisation. All of the companies that have been interested in AI security have been based abroad. They've been based in the UK, in Europe, the Middle East, and the United States. And so for the Australian government to finally put out the first AI security contract, and for us, this tiny, startup with an all-female team to win it, is really wonderful. But the reason that I mention that is because I wasn't planning on being in Australia, but we won this work, and so I wanted to come to Canberra to do it properly. And so when I found out that I would be coming back to Australia and this conference was on here at the same time, I reached out to all of my cyber friends and I was like, can someone help me get in for free? Like, we don't have budgets for like thousands of dollars to attend a conference. But I was able to get into the conference by replacing someone who dropped out of a panel. And the panel was about the implications of like AI, national security, cybersecurity. There were 3 other like amazing panelists. They came from a bit more of a like, if you're from Australia, you'll get what I mean when I say like a very Canberra kind of background. They'd worked in defence for a long time. They all ran contracting companies. They all just like spoke the language, And so one of the topics we were talking about was, well, there are a couple of points of contention. One I would like to go into in another episode, and that is, should we regulate AI? But I don't want to go down that rabbit hole now. The thing that I'm talking about today is this concept that AI security can be mitigated, or AI security risks can be mitigated by good application security, which is another way of thinking about, is AI security really all that different from traditional kinds of information or cybersecurity challenges or concerns? So that's what I want to dive into today. So first of all, for anyone who might not be familiar with the term application security, let me define it for you. So a good way of defining application security is that it's about ensuring the security of the application. So I think these days, especially if you're on the younger side, you kind of take terms like that for granted, but what an application is a software program that will run on your operating system, but the way that you secure this application is a bit like if you're building something with Lego, you could consider one of those Lego blocks an application. And if you have a secure application, then you can securely slot it into the rest of your Lego architecture. my Lego architecture of choice has always been the Harry Potter collection. So it's not so much about the security of like all the bits in the system, but by securing each of those individual bits, when they come together, you're more likely to mitigate many overall security concerns, but you do also need to do other things that are at the system level. So it's about ensuring that code, infrastructure, and data behave as they should. And a lot of the time this happens deterministically. So the kinds of things that are really important in application security are things like input validation. So sanitizing user input to prevent different kinds of attacks. So when I say sanitize, that means that we're cleaning, filtering, modifying data so that it can't be used maliciously. So if I'm interacting with an application that might take my text input, there'll be some kind of check that what I'm inputting obeys the rules of use of the system, doesn't muck it up in any way, doesn't compromise it. And you might be familiar with this idea because this is obviously quite important for a really big topic of AI security threat that is discussed a lot, and that is prompt injection. So you can imagine that if I'm interacting with my ChatGPT app, if they ensure that the input is sanitized, so as I'm writing messages and prompts into my app, that those go through some sort of check to make sure that they are okay before they're actually fed to the model, that is a part of application security. Even though it's about the security of data that is being fed to the model, you wouldn't necessarily say that that is an AI or a machine learning specific kind of defense or control. That is something that applies to all applications. There are a few other things that are important in application security as well. Things like authentication and authorization. So making sure that we restrict appropriately who can do what with an app. Encryption, so protecting data in transit. So that's while it's moving in and out of the app and between other apps, but also at rest. So when it's in a data center. Things like patch management. So for known vulnerabilities where patches are released, making sure that they are automatically implemented. And then things like logging and monitoring. So detecting anomalies in the system's operation. Those are some really important parts of application security, and there are many others. But these are, I guess you would say, pretty standard cybersecurity controls. And for any system, whether it uses AI or not, you should implement all of those things. So when it comes to AI security, you can imagine how all of those things would protect a lot of AI systems from a lot of the attacks that we tend to hear about, that would prevent a lot of issues. So let me define AI security. If you've been listening to me for a while, you know exactly how I define AI security, but it's not necessarily the same way that everyone else defines it. So sometimes I hear AI security used to mean AI being used for security. So you're using AI to do cybersecurity things. So maybe it's an AI-driven monitoring tool, AI-driven OSINT, AI-driven vulnerability detection. They're all uses of AI to do security things, specifically cybersecurity things. I often hear the term AI security used in a national security perspective too. So, for example, the United Kingdom's AI Security Institute and other states like the United States, when they talk about AI security, they tend to mean that AI should give them like a security advantage. So that's through enabling innovation that has economic gain for the state, ensuring that AI is, used safely and implemented safely, but more to protect the safety of its society and its citizens. That's AI security in more of a national security or social security context. I use the term AI security similarly to how we use terms like information security and cybersecurity, where cybersecurity is securing a cyber system from some sort of external actor who ideally is trying to, that they're trying to hack it. It's a malicious intent. AI security is the same for me. It's about securing the AI system from some sort of external threat actor that could be human or AI. The other term that gets conflated with AI security is AI safety. So that's making sure that AI does not cause harm to people, that we can use it safely, that there are no long-term alignment risks, that it might go rogue or something. But the key differentiation there is that for AI security, the threat is coming from outside the AI, whereas in an AI safety context, the threat is coming from the AI itself. And that makes a difference, because if we're thinking about security controls to secure AI systems from threats versus controls that will prevent threats happening to external systems from AI, there are many points of overlap. Obviously, secure AI is safer AI, but the kinds of considerations we have and the kinds of best practices we can pull in are quite different, depending on if you're looking at the safety or the security of AI. So from that perspective, does that mean that there's anything really unique about AI when it comes to its security? Obviously, we need to implement all of the standard best practice cybersecurity principles to protect our AI systems. And all of those important application security principles will prevent a lot of potential misuse or disruption, deception, disclosure of information from AI systems. I totally agree with that. I think AppSec is really important. But I would still argue that there are things that are unique about AI systems that mean that you need to do extra things in addition to application security. Some of them, I think, are known. There are specific things that we should be implementing on top of that. And then others are emergent risk and open questions. I don't think we necessarily have the answer for a lot of these best practices for AI quite yet, especially when it comes to more autonomous and agentic AI systems where we're still just discovering what can go wrong. But I think there are a few main reasons why AI security is different to application security. So first of all, especially if we're thinking about the context of large language models and generative AI, the attack surface, so all the potential vulnerabilities in a system, the attack surface of AI is semantic, it's not structural. So in application security, the attacker manipulates syntax. So what I mean by that is a really classic example is a SQL injection or a SQL injection. Sorry guys, I say SQL. So you might be injecting those commands into a database query, and because of the way that that input is structured and because of the way that maybe there aren't constraints on how that data flows through to the back end, it means that you can leak information or print information or enact some sort of change in the back-end database. That shouldn't happen. I'll link some examples of SQL injections below because they can get really interesting, and most websites should be secure against SQL injections now, but every so often they're not. I say that that is syntax because there's a specific piece of code that you need to submit to enact the change that you want. And even if there is one typo or an extra character or anything minor about that specific line of code, then it just won't work. The command won't work. Whereas with artificial intelligence, the attacker is manipulating semantics. There are many different ways of crafting an attack or expressing an attack. And it's not dependent on just a few pieces of a few characters, a few pieces of text, but it's the meaning of the language and the context. A prompt injection isn't just a malformed input that can be protected by the standard kinds of input or output processing rules that exist in application security, but it's a malicious instruction that rewrites the model's internal goal. And you can't necessarily escape that with typical application security controls. Some might say that AI-driven AppSec controls regarding input-output filtering might work, but even so, that is still an adaptation of existing application security controls to AI, which I think would illustrate the point that in an AI system, those sorts of controls are different. The second reason that I think AI security is different is because of the impact of data. So application security does consider data. Input-output processing is a consideration of input-output data. It talks about encryption in transit and at rest, so making sure that if data is leaked, then an attacker can't immediately see what that data contains. They have to put some level of effort into breaking the encryption to be able to see it. But the way that AI systems learn from data is different, and the way that they're dependent on data and the data quality and the integrity of that data is really important. So traditional applications are secure if the code is secure, but AI systems can be insecure if the training data is insecure. So the initial training data or any fine-tuning data. So fine-tuning data is, maybe you have a model that's already built, but in order to update it over time or for a specific task, you fine-tune it. And this can be done once so that it can perform well on that task. Often it's performed at multiple intervals so that it continues to update and stay good at that task over time and as the environment changes and the kinds of input data it sees might change. So a poisoned data set can implement all kinds of AI security issues that are at the machine learning model level. So this is where, when I said earlier that the AI system is different to the machine learning model, I think this is where it becomes really important from an AI security versus application security perspective. A poisoned data set means that you can implement backdoors, you can bias the way that classifications or predictions are made or the way that output text or content is generated. You can insert trigger words that only appear under certain conditions. So it's not just about something like a simple SQL injection, but it's about data integrity and provenance. And that's something that application security doesn't consider specifically when it comes to the ways that machine learning models can be tampered with. And if you want to learn more a bit about that, you can head to my YouTube channel where I talk more about data poisoning specific kinds of issues and machine learning issues. The third reason is, like I said before, there are still so many emerging risks and challenges when it comes to ML security and AI security. And part of that is because the behavior of an ML system, and therefore a lot of the time an AI system, is probabilistic and emergent. An AI model doesn't just give one fixed answer. It gives a distribution of likely ones. We might see one of a set of potential values. That means that security can't rely on the kinds of static rules that have been okay in application security. And the way that we continuously evaluate AI output, decisions, content is really different. And the way that we contain that too is really hard, especially when it comes to something like agentic AI, where we're starting to have to think about trust zones. So if we're implementing an agent in a certain situation, what kinds of tools can it have access to? What kind of data and other applications does it have access to? How do we manage that? MCP comes up there, but I'll also save that for another episode. But the fact is that containing an incident and defining what that appropriate zone of input and output is really different. So when it comes to the kinds of ways that we might need to solve those problems, AI red teaming is obviously a way of learning more about the kinds of vulnerabilities and issues that exist, but then implementing things like guardrails, content filters, human in the loop controls are important, and they kind of happen at both the application level and at the AI system and machine learning model level. So let's go into a few examples that I hope maybe show you the kinds of incidents that are already happening and might raise some questions for you or make you consider, where does that barrier or that boundary lie between an AI problem and an application problem? Okay, so the first example comes from earlier this year. So Echo Leak, you might have heard of before, but it's a zero-click prompt injection in Microsoft 365 Copilot. So what is a zero-click prompt injection? We know what a prompt injection is, right? It's when we inject a prompt into a large language model and it is therefore able to disrupt or deceive or disclose information from that model that it shouldn't. Usually we have to send that. There's some sort of step between the chatbot like actually being able to receive and then reply to that message. But when we have more autonomous systems, for example, like we might see in assistants in Microsoft 365 Copilot, what can happen is that an attacker can send like a crafted email to an account. That email contains hidden instructions that bypass the filters that do exist. There's specific prompt injection filters too. The exploit then leverages reference style markdown, auto-fetched images, and it proxies via Microsoft Teams to sneak instructions. So there's quite a bit of detail there, but essentially I'll include a link below to the specific article, but it's able to enact a series of steps, essentially. That means that the attacker forces the Copilot instance to read and exfiltrate internal data from trusted sources. So what that means is that it's across those AI trust boundaries and that it's all automatic. So because it exploited the AI prompt handling pipeline, the attacker could escalate privileges. So that means that if you come in through the privileges of a typical employee, you want to try and escalate to admin so that you can do more stuff, essentially, without triggering classic network or API application interface, application programming interface controls. So the kinds of standard application security measures that are already in place. So the reason that this is beyond AppSec is because it doesn't just rely on a bug in like a backend code or an API. The input is just an email, and you can't really prevent an email from, well, it's harder to prevent an email from being received. Even all of the automatic checks were still able to be bypassed in this instance. And then the AI's assimilation of the hidden prompt lets it bypass boundary controls, which is something that app logic wouldn't permit. So there are things here that we can do that are specific to AI security that we should implement. So things like isolating the way that prompts are received by the system. So you would have to separate system level instructions from user generated content. So the way that, like if a machine receives those prompts, the way that it's able to enact those needs to be based specifically on what that user profile can do. It shouldn't go back to the entire system. Things like enhanced provenance checks, more specific content sanitization in AI pipelines would help. And then red teaming is always really helpful because if there had been more red teaming, maybe you could have caught something like this. But the good thing is that obviously lessons have been learnt from this attack, and these kinds of, every time that these kinds of reports are published, the vendors are really, really quick to reply. I'm going to drop a few more examples in the description below because I can't believe that it's already been 30 minutes. I thought that trying to solo record might feel like it'd feel really slow. So I don't know. Let me know if you have any feedback on this new style. Should I speak faster? What kind of content do you want to see? Thank you so much for being here and for being part of this journey. I really am keen to get different suggestions on what you want to learn about. Sometimes it's really hard for me to get a sense of what everyone works on. Typically when I interact with people and viewers and followers, it's a real mixture of like cybersecurity professionals, IT professionals, students. So let me know, and definitely open to your feedback. Something else I want to highlight about the AI security versus application security question. The reason that I think it's important is because it's not necessarily about making it seem like AI security is more important than application security, or that it's more important than other kinds of security, or that it's really that unique. But the perspective that I come from is that I spend so much of my time trying to convince people that they just need to care about AI security at all. So if your security toolkit in an organization, or like your skills, if it includes at least a little bit of everything, and ideally it must include some awareness of AI security specific techniques and risks, then I think we're off to a good start. But if you have, if you come from an application security background, if you've seen cool examples, if you've seen anything specific, please let me know. I definitely want to hear from you. Before I let you go, again, please follow, like, subscribe, comment, and you can sign up to the newsletter. I'll leave the link. You can get access to the pre-release version of the book. That's really great. And stay engaged. I'll see you next time.